All right. Thank you very much for the introduction. And my name's Thomas Robinson. I'm the founding principal of Lever.
I'm Chris Gross. I'm a senior associate and project architect for the project.
And we just want to have a conversation about the Adidas North American Headquarters project. So we've probably never shown as much on this project to anyone ever. So we're going to make sure that we are done at 5:45, but hopefully we'll cover sort of the objectives that were set out in the synopsis. But I think we're also just going to have a little bit of a conversation about our experiences. So to give you going forward this. There you go. There we go. So to give you, let me see if it goes forward. There we go. Yeah, it's working. I think what we'd like to do is just get through this in about 45 minutes and then have opportunity for discussion. But hopefully we'll answer many of your questions on the way. Adidas North American Headquarters is around a 450,000 square foot project when you include the parking garage, which is underground. There's like 600 spaces. The building you see on the right was 180,000 square feet, and then it's called the Gold Building, and then the building you see on the left is the performance zone, and then there's a landscape component and other pieces that connect back with the road. But at a really high level, one of the fundamental goals for the project was really to reimagine how you enter the campus. For those of you who might have been to the Adidas store when it was actually located on here, it was sort of a parking lot. You kind of went in, and it was a little bit of a mismatch with a roundabout that was a dead end. So they really wanted to say, hey, this is a global brand. They wanted the experience of the campus to be, to sort of equate with, the prominence of the company. And so I'll talk a little bit about that, but I think just some of the history, there was a competition where they pre-selected about 6 firms that we did very quick. And this is the model that we made that went off to Germany and never came back because it was like broke into a million pieces. But I think it's interesting to sort of see this was the initial ideas that really formed the building, which is really, we actually broke the program apart where we said, hey, an office building, we have this sort of central pitch, which we reconfigured. And then we had this other idea of a cafe and a performance zone, which is a state-of-the-art gym. So it actually wasn't really necessarily totally in the brief that way. We had food, service, and cafes in both that were a little different, and a landscape connected it. One of the key things that we wanted to make sure was the building reflected the kind of ethos of the organization. And some of the things that Adidas has been involved with is the Ocean Plastics Parlay project, where they're actually taking fishing nets or plastics from the ocean and using it in their footwear. And the turf field that's actually out there is, I think there's hundreds of thousands of recycled bottles in that turf field. So Adidas, we wanted something to sort of reflect that kind of engagement with sustainability issues relative to clothing and shoe production. But also, I think Adidas as a brand has a legacy that is specifically focused on reinventing the historic kind of shoes that they have with different materials and with subtle variations on that. And that's something that we wanted to also explore. In terms of the site and the landscape component, we don't actually have a before. We should, but I think this is important. This was actually Kaiser Permanente Hospital. Some people who worked on the building were actually born in this building. But one of the things that was not the case, and I wish I could have had all to do this next, this was a parking lot here. And then this entry, this didn't even line up. And this was like, you would actually drive up through here, through this roundabout, and up into the parking lot. So it was a real mess. And so what we did is realign the sort of connection, working with GGN, which is a great landscape architect that I've worked with for a long time out of Seattle, and to really kind of come up with an entry sequence that could work. And what it had to do was also, you had to be able to take a full-size bus and actually kind of come up here turnarounds. The athletes could just drop off at the top and then come back down. And then this is the entry here into a 600 space parking garage. And then this new sort of plaza, the heart of the campus with the pitch, as they say in Britain, and then the sort of back end here of the performance zone, which was originally actually tennis courts sitting on top of the existing parking garage. But the idea of sport is central was really a key part of it, and having this sort of central plaza that was also a place where people would work. And these are some of the, just to sort of show how the landscape kind of navigates this somewhat, unusual. I think this building was done by Bora in the 90s or something. And it was a renovation, and then we have like single-story houses, and then our building. So it was quite a kind of thing to thread all these elements around. So this is some of the landscape components in the sense of the connection of the interior to the outside, and then the landscape becomes a major element within the project, because we're trying to soften the edge as it comes to the neighborhood. And this is where the buses come up now. So it's a whole new entry sequence into the building. And since it's only like 10 minutes away, you could literally go there and walk or drive over there in about 5 minutes from here after this presentation. It was still only light. So GGN really worked on this, creating this really beautiful kind of buffer zone with these buildings, which are quite large, but we think actually strengthens the urban character of the landscape and the connection to it. So you can sort of see here the building in the distance. So I'm starting kind of to talk a little bit about the gold building, which is the larger of the two. And you can see here, this was an existing parking garage that is actually connected all the way to, the major street that fronts the campus. And that's where you have access into this parking garage. You'll see it as you're coming up Greeley there. There's these entries into it. And what our project was is actually grafting on this new parking garage, putting a building on top of that. So this is actually a 10-story building, count the parking. Then adding this all timber building on top of the existing parking. So it had so one of the things that was a key part of the project, and you can sort of see here, I just want to show quickly the kind of basic RT of the plan with these two concrete cores. These all go down, and they're all sort of expressive of the parking grid that's down below, but it gets bigger. One of the things that Adidas wanted us to do is they had a specific budget of 175 million. They had a timeline where they wanted us to build it 3 months faster than a traditional building. So we actually ended up building this entire project in 23 months, right? Which is pretty fast. And one of the ways we did that was to look at prefabricating as many of the elements as possible, and also sort of leveraging the fact that we're doing a parking garage, which will probably be concrete below grade, and using prefabricated precast elements to do that, and then actually extending that and creating this hybrid building at the top. And I'll show you in more detail how that works. But this is just giving you more of a sense. Chris will talk about that a little bit more detail as well, of this entry sequence where they would have whatever UCLA come up, unload the bus, and have this entry sequence. And that's there's a bronze statue right there that you kind of see of Adi Hassler, so the founder of, so you can get your picture taken for that.
We have another one in Germany.
Another one in Germany, and another one in all the different products. And then this is the sort of trick of this is still a very large parking garage. It's also their loading dock. So this is, the kind of, the idea with this was really to create a system that could work with a plank, precast plank below grade with the parking, and then we created this perforated. These are the early renderings of this original system that we worked in. I don't know, Chris, what did we work on? We worked on how many different schemes?
There was a lot of schemes. I was talking to somebody earlier about the all precast version, and really, we mentioned that it was a competition, but a part of the competition team was an interiors firm out of the Bay Area named Place, but also Turner Construction. And so we had this kind of hand in glove right from the get-go. And so the drivers of the project could be, and the kind of structure and prefabrication could be studied both from a design perspective and planning out systems and keeping the system as efficient as possible, but also like real life pricing, schedule implications. So the structure allowed us to reduce the project schedule by 3 months while keeping it as a cost neutral change from a traditional PT structure.
Yeah, this shows it best. I think you can see this traditional PT. This is a beam inverter system. Doesn't have the retaining walls, but showing you how this is traditional plank structure, and then it sort of transforms into this slightly different. But it's actually taking that grid, all the way up. And this image really shows you how that was done. So I think there were about 1,000 precast pieces and like 550 like planks or something like that. And then this is the really basic detail of the sort of building blocks, the DNA of the building. So this is that, it's basically this 3-ply panel, and they're all running in one direction, and then the glulam's are prefabricated onto these and attached, and then there's a concrete plank. So these diagonal screws you see here are also there for vibration, so it ties the concrete into concrete slab that goes into the concrete cores back. And this is the kind of more sort of radical piece that I don't think had been done before, which is developing this sort of perforated precast girder, and sort of figuring out how we could do that. And it was really done with like everyone at the table.
Yeah, very early, we had to, nail down the general approach, but then we get into it with, once we involve a precaster, we have their engineer at the table as well as our engineer. So there's that kind of like tension of that mix, and, our engineers like, you could put holes in this and bigger holes and more frequently, which obviously we're behind them pushing for. And then, but we also needed to be conscientious that by building up a thicker floor assembly with girders and beams, that we weren't blowing the height of the building and, ballooning our facade enclosure, and kind of finding these balances between finding the right size. So really early on, we had to map out systems, determine a kind of on-center spacing of duct distribution on the open office levels, and then sprinklers. And that kind of led to that perforated scheme. And then refining kind of typical precast elements, which this is our visit to Knife River's yard.
This is a plank, you can sort of see it. And you see how it has a lot of camber on these parking structures. That's something to be aware of if you're ever doing this again, is that we a lot of camber. That parking garages don't really care about camber, but offices a little bit do. So it's just interesting, these sort of, and this is the sort of such down and dirty. This is the typical precast girder, and then the planks just sit on the sides, and then the stirrups tie into the slab. So these details look really kind of dumb. They are, and that was sort of the intent, is to like, on this project, there's no machining of the timber. So like most, like this thing, it's like they've got lots of machining and everything you see, and this, there's nothing. Literally, straight cuts, and then there's glued on, and then they're sitting on a Teflon plate, and they're just sitting there by gravity, and they get tied into the stirrups and to the reinforced concrete topping slab.
So we took this kind of traditional inverted T and then started playing with it, get some alignments from column to girder, and then the penetration, and again, pacing this out with our like 5-foot on center beam. Aligning with like a optimized 10-foot CLT panel, and the whole building kind of takes off from there.
This is kind of a little piece of history. This is like the first CLT press in Oregon and in the United States. And it's not, I don't think they're even using it anymore.
It's for sale.
It's for sale. You can buy it. So, but it's interesting to see how, and they probably won't use it anymore because it's a pneumatic press. It was like a one-off type thing. But I think that both this building and Adidas are built using that press, and it's kind of this early Oregon, innovative set of projects. But one of the ways we were able to actually do this and really work with the contractor was we did this, and the client was really good to allow us and pay to do this sort of mini-me mock-up where we could have, and that's something that we do a lot in our work. And people are like, well, why is it so resolved? And it's partially because we have this ability. We always try to engineer in this practice building. It's not so much a mock-up as it is getting all the trades that would actually do the work to work together on a sort of smaller piece with all the kind of key details in it. So it's not necessarily very attractive.
So this was, yeah, Turner used that for a million things. They tested cleaning stains, because this sat out in a rusty yard in St. John's for probably too long.
Yeah.
And cleaning stains, they brought the electrician out to like test their conduit bends to determine how we were gonna get up out of the slab into walls. And then we used it for our facade mock-ups where we had skyline, do all the metal work, and Culver glass, do the curtain wall and glazing. And before that, even, you know, some generous mock-ups of the facade system.
Yeah, and one of the things, like this project, you know, we had a very fixed budget, so we really had to work with it. So this is, I think, an interesting mock-up because the size of these panels, you can see here they're short, but you can see here that's the full height or close to the full height, not actually the full height, it's taller than that. But we're optimizing the cutout of the ACM panel. So we just did this really simple 12-inch, approximately 12-inch panel that gets folded back, but it's always the same panel, we're just flipping it.
Yep.
And then what was for us, it's like the abrasion you do on like if you look at a material and you grade it and it looks flat in one way and it looks different, really different color in the other. So the building itself has that quality where, you know, this is all exactly the same color silver, but you have 1, 2, 3, 4, you know, 6 different readings of it, just depending on, you know, how you're looking at the light. And it's amazing because the building actually has this slight deflection, but in certain lights it looks completely flat, but then as it changes throughout the day. It's just this is an early construction shot. And what's amazing is people have no idea how big this hole is. It is huge, right? I mean, huge hole in the ground.
In order to meet the schedule ambitions, we had to do a lot of things at the same time. So we won the competition in 2017, and less than a year later, we had a permit to dig the hole. And then Turner dug the hole, mass excavation, start working their way out, and you can see
This
this
is
like
February.
speed of
That's
direction after that, which is kind of the proof of concept of the schedules that get done in Excel spreadsheets and everything.
Yeah.
And then the performance zone was going up over the top of the existing parking garage.
That's
and
1 year later.
Yeah. Caught up much faster.
Chris, I feel like you're like the worst ball now, but I was always wearing the same shoes. So I think this was like the first set of panels going in. The first 4, you could sort of see them being lifted into place. They would come like stacked 4 high, right, on these trucks. Then they would line up, and then it was just really elegant to see these panels going in place because literally, you know, that was it. Basically, presto, had your building pretty much done. And so
that first day we should have thrown a party. And we had like it was just like everybody who had been on this project for a couple of years at this point was just so excited to get out and see the stuff start arriving on site.
Yeah.
The Turner would joke that like Thomas kept showing up uninvited to take photographs of things. It was just like just the real buzz of like, oh my God, we're doing this.
Yeah, it was really nice. And it was done so fast. I mean, basically they built 180,000 square feet of building in 2 months. Was it right? Mm-hmm. Yeah. So in the middle of the winter, it was raining the whole time. So that's what they did. So everything above that podium was all done in like literally 8 weeks. So super fast. They had the iron workers actually doing the erection for the timber, which was really great. And I think that's one of the things with these types of buildings. And you can see these sort of massive cantilevers that we have coming out. I mean, this is a really nice image, which we don't show. And then that's translates into the actual office space. You can kind of see it, that's the entry. And then just sort of areas where you can kind of, this is a good shot because it sort of shows on one side, we have 2 bays in the plant. And on one side, we just have a main running down, and then it just pops the mechanical up into the other cassettes that we have there. This is probably one of the nicest fire stairs in Oregon. But I think one of the things we've found, and with this building and all the buildings we do, and this is partially due to the way the code's written in the United States, is even in a building this small, you need 2 separate fire stairs. So, and Adidas, we sort of supersized that. So there's only 2 fire stairs, and this is one of the primary ones, but it's also, you know, basically isolated, and it's, you know, has a skylight that goes all the way up. And you probably might, if you know Adidas shoes, you recognize these tread patterns as they go different types of historic Adidas shoes. So they also have a major cafe space, and the elevator. This is done with a plus a studio, so a lot of branding. And this is sort of an event space where they do their presentations. They, you know, worked with a lot of muralists, and then they also have these sort of more open meeting type spaces, just showing you a variety of like the experiences. And I think, you know, we really worked hard to really make the mechanical seem sort of straightforward, but also considered. So that was a big challenge, was just to sort of say, hey, we're not hiding it, but we're also trying to organize it in a way that seems to make sense for the building. So it's not always perfect. And then also knowing that down the road, they're going to come back with other, you know, with other utilities. So the idea is some of these holes don't have things, or they have the space to add, you know, new equipment, or rip things out, or, you know, I'm sure it'll evolve over time. So that idea of, you know, maybe down the road, they might rip all of the mechanical out and you just have the structure, and they do a completely different system for the mechanical. And I think thinking about buildings as having multiple generations of use, and so not being absolutely specialized or always just doing exactly what you need at the time. But this gives you kind of
a good shot of the panel.
Yeah, it shows you like the way these panels sort of evolve during the day in different light. And then I think you could sort of see here, like, you know, the differential between the lower panels and the upper panels, they're just flipped the other way. So it's always, what's kind of exciting about this building is every single window above the datum is the same size. You know, so but it doesn't look like it. Every single panel is exactly the same width. So I think what we find interesting is when you can develop languages that allow you to do something that has a richness, but is not necessarily more complicated. So, you know, we are very keen on like, okay, what's the biggest fiberglass window we can get? Let's just do all of them that size. And then everything else could kind of vary through that. I don't know.
It's always, yeah, I think one thing I love about this building is the legibility of it for looking for a term, but like the contractors or people from the client side would walk by as it was being built, and they're like, are these different panels? And you're like, no, that's the same thing. And you're like, yeah, that was like what we intended, and you're witnessing it just as a kind of passerby. It's nice when these things kind of translate to people and they can make observations that, you know, were set forth well in advance.
So just another view. I mean, this is actually a view we don't show, but it's a nice view of the building, because it's the real approach view as you come into the campus, and as you actually, there's an entry space. You come up here, and then you sort of look down over. If you do that, it's kind of a nice way to walk up there. And then as part of the design, we actually kind of created a new park, which is what this picture's taken from, which was actually, there's a big sewage main that comes, or water main that comes through that, so they had to have access. But we created,
like negotiate with the fire department to keep their roundabout or minimal, so we could add more planting and all that kind of stuff. It's really fun.
Yeah, but I mean, the building, I think what we were excited about was like that it's very straightforward, but it's still dynamic. There's a courtyard. This is actually here. There's 2 cafes. This is a big eating area, and then there's an outdoor kind of eating space as well. So get a sense of like, one of the things that is unusual about Adidas campus compared to like Nike or other corporate campuses that we've worked on is that it's actually open to the neighborhood. So a lot of like, I worked on Pixar's campus, fully gated. Nike's also secured. But this is a really unusual kind of arrangement where there's actually public easements that go through the campus, but they still own the land, you know, it's still private. So, but one of the things we wanted to do was also create spaces for people that are sort of behind the perimeter, you know, or are employees, but feel like they're still in the landscape. So that's sort of the reasoning for these sort of elevated, this is like a, you know, seating area that's sort of almost like a, box seats in a stadium, you know, that would look out over the thing. And then there's places that are more public here. This is actually bike parking, and then this connects into the existing building here, and then underneath, back behind there is all the loading. So super complicated. And then this is the exiting from the garage, and then this is all the exhaust kind of piled in with the
vault over there.
The vault here that took us like 6 months to figure out. So that gives you kind of a good sense of the goal building. Performance zone, very different building, but the idea of creating a state-of-the-art gym that basically spans over 3 levels, but also has a cafe on the 3rd level and a roof terrace, and some actual sort of more intimate meeting spaces. But because this building, this parking garage was really originally engineered to hold a new building, but we were able to actually do technically, which is a 4-story building by because it's out of timber. So this project's completely timber. You can kind of see the plan here. We have our 2 stairs here, which are very carefully calibrated to be just the distance that we need them to be. And then this is also an open fire stair with a wand door. And then you can sort of see the gym element and then the roof deck. So one of the things different about this building is we're spanning the 30-foot grid on the parking with timbers. That's why we have the double beams, which is typically what you need. And it's a different structure in that it's a BRB steel brace frame, which is in the center, and then the structure's tied to it. But one of the exciting is see, this isn't how it was built, but it just variates all the different systems. I don't know, Chris, if there's anything you wanted to kind of talk about with the way.
Yeah, the structure was originally designed to accommodate a three-story steel building, but we were able to do a little bit more with timber being lighter. There was some fine.
It's technically a 4-story building.
Yeah. Yeah, and the paired beam as well as the cantilevers that we see on the gold building create that kind of central pitch, kind of stadium atmosphere where you can kind of be, in this case, at work and like see your colleagues having a game in the middle of the day or whatever, and kind of reinforcing the central idea of Adidas, which is about sport.
One of the innovative kind of connectors on this project, and this is going back to the theme of simplicity, because one of the things we've been really focused on as a firm is all the projects that we've done are sourced on the West Coast or in the region here. So and that's been purposeful, because like I used to work in Europe, and I know that Europeans can do all this stuff probably for less money and faster. Because everything's so much more advanced. They have the robots already in place. We're building some new mills that'll probably be as sophisticated. But so one of our goals was to create the simplest amount of machining so we could be competitive, because literally there was no machining. So on this project, on this piece, the only sort of major machining is they had to drill a hole through the column and then epoxy this big piece of steel in the middle of it. And then they had to like basically route out the same thing in these big beams here. And that was it. That's all the machining on the whole. So on the other project, there was nothing except cutting the CLT, right? Which you could just do with the saw. And this one was that. And the reasoning for that was that it allowed us to actually kind of bury the joint in with the wood. This just had to be a rated structure. And then really use the sort of fact that the wood was pretty economical, and we had a lot of it. It was only coming from 3 hours away, to kind of create this sort of simple connection. And then it's sort of like a Jenga block. It's also, inspired a bit by Japanese architecture where you have the tendon, the timber, and then we actually just mount these beams from the side and screw them in and do bearing screws. But this was built so quickly. So you can sort of see that BRB steel core here and then how it connects in with these double beams. And then you can sort of see how these pieces are sitting there and then they come up, they sort of have the beam in the air and they just sort of just push it into the thing and then screw it in.
The steel here, for knowledge, is just a vibration steel. It's not structural.
Yeah.
It's essentially just because we have a bunch of people jogging on running machines or whatever above a.
Yeah, like so that was a little bit of a kind of, probably in hindsight, probably not a good idea to have a big cantilever on a gym. But it happens. So yeah, this gives you a good sense of like the sort of columns that go through, and then just these beams that are sitting on top, basically gravity kind of loaded and just held in place. But once it's loaded up, they're sitting there. It's another shot to give you a sense of the structure, the big panels.
Similar to the gold building, and what we try to do with most of our timber jobs, think about systems well in advance. So another reason for the stacking method is you create kind of primary and secondary distribution pathways for mechanical. So you'll see in the finished photos, mains will kind of sidle up to the paired beam and then they pop up and they have a clear run the other direction in the building.
Yeah, you can see that here.
And it kind of moves them up and out of the sight line a little bit.
Yeah, you can sort of see that in this image here where you're looking closely. So we have this mains that run back to the core, and we're doing something similar, and then it just kind of just basically pops up over the beam and runs the whole length of space. And I think that's something that in doing these timber buildings, really thinking about the mechanical runs and really working in, probably more closely with the mechanical engineers than they actually like. But, that's really been critical to the work that we've done, is to really think through that element of it.
So that's the juice bar, the roof deck.
Yeah, so it's another view of like, activating the space, but it's amazing when you get up here, the views, you can see Mount St. Helens in the distance and the buildings. And both these, this building has full solar. These are both LEED gold. And then we, in terms of the, it's interesting because we did a carbon analysis at the University of Toronto. Architecture school did this carbon analysis and incredibly good ratings, even with the concrete structure, because we were actually coming from so close, both in terms of the precast that was, and then also in terms of the timber.
Yeah, all told, it was 2.4 billion or million square feet of lumber. So that's a lot of carbon sequestration.
Yeah, it's a lot of wood. So this is just the gym area coming into it. This was done, branded by O+6 Studio. So one of the ideas here, this is like an outdoor sports court. So this is all like rubber flooring, so that we actually designed this cantilever structure so they can do exercise outside. So you can kind of see sort of, these are you can sort of see these are some of the screws that they use to basically pull the beam onto that, and then it's bearing on these structural screws that are actually, I'll show you another view, you'll see them in another up there. You can kind of see, you see these holes here, those are just bored in, and then they actually take a long screw and they screw it up so that it's actually sitting on top of that dado element that's taken out of the wood, so that the actual steel is bearing on screws as an additional reinforcement. So, and then they just basically fill those with dowels. So, an interesting structure that I don't know.
Half of securing the beam and half of keeping the beam from delaminating it.
Yeah, exactly. So there's a double extra. Like you'll see it's the same thing we have here. These are safety screws at the end. So those aren't really structural. It's just to like, if the beam splits at the end, they basically hold the connection together. So we're actually, it's not a Sherpa connection, it's actually a tube steel that's like divoted into the end of that beam. So just give you a sense of the structure, how it kind of works. Different spaces. So they all have a little bit different character, but all the same sort of expression of the timber structure. The cantilever.
This version of the open stair.
Yes, another fire stair. So I think what we really worked on is, and we found that in these types of buildings, is like, if you want to have a circulating stair, you need to make that a fire stair. So trying to figure out ways to make that work both as a fire stair, so as something you can circulate. That's a view. So thank you. We got done a little faster,
Yeah.
but that was fun. We could play the videos. People want to see them. We have videos. We have videos. I think we do. Oh no,
I don't know. We have them ready here.
Are there any questions online? Kathy, have you seen any questions come through?
No, there aren't any online, but you guys online, feel free to put your questions in the chat. Is there someone there? Is there someone there who can see them?
yeah, let me look. Let me try to bring up the chat. I probably have to stop sharing up here. I do not see any.
Go ahead.
There aren't
Any
any.
question here?
In the early iterations, did the gold building start, or did you envision it as a small timber building on top of the for the apartment structure?
I think primarily, we looked at a lot of different structural solutions, and one of the drivers was always speed out of the ground. And so when you think about that, like the real natural place to be is a 30 by 30 grid. It paces out well for drive aisles as well as parking stalls. And we solved it with the performance zone, with the pair of beams. But the gold building, we wanted to avoid just transferring out a bunch of stuff. And so, and then as I mentioned, the kind of height of the building relative to average grade plane, and the kind of avoiding ballooning of facade costs by adding a bunch of square footage kept us on this path of like how we keep the floor to floor efficient, which is only 13.5 feet, which is part of the driver for like penetrating the girders and things. But so the precast really lent itself to accommodating the 30 by 30 grid and just kind of running our columns straight up through the building and letting all those systems kind of track through. Go ahead.
One, ready on site solo.
Yes.
Yes.
And two, was that gold building facing soccer field, was that facing south? Any issues with that?
Yeah, you can.
Like glass.
So yes to rooftop solar, maximize as much as possible with the solar studies that were done. Given we have mechanical up there and the kind of natural shading that can occur. Interestingly, we also layered green roof over or under solar, so we did both and then yes, south facing glazing, a part of the vision of that kind of stadium effect of looking down on the pitch led us to a lot of glazing on the south end, which you can see in this image, pairing the additional solar load with the cantilever, which forced us to drop some of those penetrations, kind of drove the mechanical solutions at that end to be a little bit more onerous. But yeah.
Yeah, I mean, I think one of the things we did was, that's one of the reasons we added these, this steep cantilever, so basically shades all this glazing. And then we actually calculated the shading on this, and then all these have like 12-inch fins on them, so as the sun comes around, it actually blocks some of the light, but
Custom
Yeah,
mullion
the
cap.
custom mullion cap, but you know, this is where it's like, you know, the field happens to face south. You know, so, you know, I think what we felt was like, okay, we're gonna do punched openings everywhere else. But you know, in a way, south is like the easiest kind of with some cantilever, it actually reduces quite a bit, shades the building quite a bit. You know, it was surprising to us to even have just, you know, 3 or 4 feet there. It makes actually a big difference in terms of the solar gain. And then, you know, the worst ones like the east and west, it's all punched openings. So we also on these 2 directions, we just went with a much higher shading coefficient on the glazing. So it's pretty you see, this is obviously at night, but I think there's a view in the daytime where it's pretty reflective. You can sort of see here the depth of the fins. So as the sun kind of comes around, those fins actually cut down on the heat gain quite a bit. But you know, this is sort of the architecture you can kind of see on that one. It's kind of blazing. So that was definitely intentional, and you know, I think if it was a bunch of punched openings, it just wouldn't have like worked relative to the idea of it opening out onto the field. So
The cantilever aspect of it was a fun one, being that we had such a layered structure. So a lot of the massing moves you see on the gold building are derived from the maximum ability to cantilever one element or another. So the second floor can come out, I think it's an 18-foot cantilever with precast, which is like our strongest thing. And then on the short sides, we were able to get that kind of meandering facade that stair steps
just from the CLT.
with the strong axis of the CLT, and then we get a little bit more with the weak axis of the CLT again on the south side of the building. And then on top of that, some steel to like add some more expressive shading elements to the building.
Y'all gotten much like the science feedback yet on like to the client side of like now that they're looking at it, like what's working, maybe things that they've had to pivot or adjust?
I'll repeat the question. There was just a question about, you know, have you gotten feedback post occupancy, you know, about things that have adjusted. I think the feedback is everyone wants to be in these buildings. So that means like that means they've, you know, probably move some of the, you know, the top executives from other buildings into these buildings. So, you know,
That happened almost
immediately. So basically, you know, people love these buildings. People come from Germany. They really, you know, love these buildings as well. I think they're really, you know, I think they work and they're pretty flexible, I would say. So have we done a formal post-occupancy? We haven't, but in general, they seem like they've been really a success. So we haven't maybe had to do that, find out what's wrong. But yeah, it's been, you know, I think the hardest thing is just, you know, it's Adidas, so, you know, it's harder to actually, sometimes they're using it a lot. The reason we couldn't go visit today is partially because they have like the entire like contingent of people globally coming and having a meeting this week. So it's like a couple hundred people, I think, that are flying in here, you know, post-COVID.
Is there any challenges, design challenges, and like balancing the corporate design standards between that and your intention of creating space with locally sourced material as much as possible?
I mean, you know, I think that we worked, Opalese Studio, we worked really hand in hand with them, and they did the branding and the interior work. So they were looking to do something a little bit different, you know, and than what they'd had previously in other places, something that was more welcoming. And
they had to deal a lot with like a new concept that they were rolling out for like how officing was going to work and hoteling.
yeah.
So there was this whole concept of nobody has a desk and everybody's gonna show up and you can squat, which is why you see all these like storage units. And that kind of like, there's a whole like under layer of systems enabled to allow them to use the building like they were using their new buildings in Germany, for instance. In terms of like the aesthetic and the structure, the core and shell aspect of it, Adidas was attracted to the wood and the hybrid systems because a part of their brand is about like an honesty of material. And you know, we talked about the Harley, and so they're very interested in the materiality that can exist. And so the structure kind of gave us that, and they were very much on board once it was presented. You kind of like put it together and you have this kind of raw, honest aesthetic of material.
Yeah, so I don't think it was really, I mean, and also we were doing the whole thing during COVID. So, you know, when you know, the whole thing was built, you know, I guess COVID started right.
Yeah, there was like a weird pause and then a reopening. And
yeah, so the whole last piece of construction was during COVID. So it was all sort of online at a certain point.
Did y'all have like conversations about the workplace during that where it's all totally changing? And then kind of went back, but like
not really, because it was all sort of already baked, you know, at that time, by the time, and it was very, I mean, I think, you know, like, I think at one time we had operable windows everywhere, and they were engineered, you know, they were taken out of the project as a maintenance headache, and I'm sure that, you know, probably people would have enjoyed just having the windows be more open or having more space that was accessible. So
kind of maybe accidentally, you know, like when you're doing offices for people and you're thinking about that when you're designing, you kind of accidentally can fall into like good practices with this kind of thing. Like there's a lot of outdoor space accessible for people when they're eating and not wearing masks. Stair is overly generous, so like you can kind of pass by people. Circulation is generous, so there's a lot of like just good practices that I think worked out pretty well.
yeah, I think yeah, that was it. And it's interesting because I mean we just finished a project in LA which has all operable windows, porches, and it's a hybrid steel and timber building, and that was a little later on. I mean, a little later on, and we kind of amplified some of the landscape components and connections at every level, as opposed to here. Originally, we had like a roof terrace at every level out the back, but quickly got kind of fixed for cost reasons, or people like, oh, nobody's going to use those terraces, you know. But I think in hindsight, that would have been really nice, you know, during COVID to have those. But we still kept the roof deck on the performance zone.
Yep.
Yes. So maybe a last question, if people have a question. I don't want to.
Do you have any more projects in the future that maybe utilize a similar hybrid system?
We don't have any that I can think of, not with concrete and timber right now, right?
Yeah.
I mean, we've done more that are steel and timber. Though we hear rumors of people, you know, doing this or trying it out. I know there was a couple of European projects that I saw happen like two years after this finished. So it's definitely, and there's actually European industrial facilities that we've seen. Haslacher has an outdoor warehouse where they have a concrete column and steel with glue lamps. So we think it's a really robust system that could easily be like a high-rise building, you know. So it's actually, we think for high rises, this could be a really great kind of option, because it's like a really 3-hour, like a 3-hour structure.
I like the question because I think a nice part about the project, one of the best parts of the project, was working with the same team, both from the interior side but the contracting side for so long. And everybody gets really invested in solving the problems that the project presents. And the superintendent for the gold building at some point during construction administration was like, you know, next time we do this, you know, like prompting me with like, how we could do, I see all these things now. And you're just like, kind of like, dude, probably not. But Yeah, like I would still love to like debrief on all the little things, cause.
Yeah,
You know, they're solving problem, like. As architects, you go through all this design and engineering and documenting, and then there's always something that shows up on site that you weren't anticipating, and they're there because they've been there all along to like pick up those things and continue to solve them through construction.
yeah,
And so there's like little gaps that we needed to like get black sheet metal to cover, so it was like in the shadow and kind of up in a pocket, and like you know, there's just a lot of problems that get solved in that way, and it's just like it'd be great to do it again, and then like, you know, narrow the window of problems you're solving on site or whatever. But I think the question and the like kind of interrogation that would happen on the project was like a reflection of how embedded the teams were with one another.
yeah, I just think last thing, you know, I think that, you know, the collaboration that we were able to have with Turner. And it's just the fabricators really was sort of root of the innovation that we were able to kind of successfully execute. And I think, you know, Chris, I mean, I don't know, Chris, you know, pretty much put together the whole set. I think we have like 1,000 pages of drawings for this project. The whole was about 1,000.
Yeah.
Probably. And how many architectural, probably like, I don't know, a couple.
Yeah, I mean, we had like, I was telling somebody who was a precaster.
Yeah.
And it's like, you know, we all of a sudden had 2 engineers and they all had their sets of drawings because the precaster engineers around the thing. And yeah, so you generate a lot of drawings for 7 permits. And
Yeah, we had, that's the thing that we did really last, you know, that this is all fast tracked. So we had 7 permits for the project, all running concurrently.
Wow.
On 2 buildings.
Yeah.
So it was pretty intense. So I think, so we're happy that everyone seems happy. So thanks very much. Thanks for coming to Lever.
Thank you so much for this.
Thanks, everyone online. Appreciate you joining us. And let's give one more round of applause to Lever. Thank you.